Hello everybody and welcome to this tutorial. In this lesson, we are going to talk about data normalization. First, we will define data normalization in general. After that, we will define first, second, and third normal forms, and we will walk through some examples together. Data normalization is one of the key terms in relational databases. So in order to design and develop a relational database, you need to have a very good understanding of data normalization process. Basically, data normalization is a set of rules for storing data into tables in such a way as to eliminate certain types of redundancy and incompleteness. The photo on the screen shows the normalization process in general. We will talk about all these steps together and we will walk through some examples. Before talking about data normalization, we need to define some of the key terms in relational databases. It's really important to understand these terms in order to understand the data normalization process. Here, we are going to use employee table as an example. As you can see, employee table has three columns: employee number, employee name, and department number. It also has some rows, and as you know, each row in the table has the information for one employee. For example, employee number 1267 is Clark, who works for department number 5. The first term that we are going to define here is primary key. In this example, employee number is the primary key of the employee table. Primary key is a column in the table that uniquely identifies every row in the table. For example, all you need to know is the employee number in order to be able to find the information of that employee. If I tell you who's employee number 1267, you can simply go to the table, find that employee number, and extract the name and department number of that employee. So employee number has to be unique. It means that you cannot have two employees with the same employee ID. Also, employee number cannot be null. In other words, you cannot have any employee without employee number. In order to understand the primary key, think about your student ID. There is no other student in the school who has the same ID as you. So your student ID is yours. Also, you cannot have any student in the school without a student ID. Let's look at another example here. Department table. Department table also has three columns: department number, department name, and department location. Can you guess what the primary key is in this table? You are probably right. Department number is the primary key. It's unique and it's not null. Next term that we are going to define here is the foreign key. Basically, foreign key is a column or combination of columns that is used to establish and enforce a link between the data into two tables. So in this example, department number in the employee table is a foreign key that refers to the department number in department table. Let's talk about foreign key a little bit more. If I ask you, what department employee number 1267 works for? So you will go to the employee table, find that employee number, and look at the department number. Okay, who works for department number 5? But you probably need more information about department number 5. So you have to go to the department table, find department number 5, and retrieve the department name and location of that department. So here is the key. Foreign key in one table has to be the primary key or has to refer to a primary key in a different table. In this example, department number in employee table, which is a foreign key, references the department number in the department table, which is the primary key. Let's look at a different example here. Order item table. So order item table has 3 columns: order ID, item ID, and quantity. If you look at this table, you will see that there is no column that uniquely identifies the record. For example, order ID 101 has 2 items, item 2 and item 3. That's why you cannot find a single column to be used as the primary key. In this case, you need to find the combination of 2 or more columns that uniquely identifies the rows in the table. In this case, item ID and order ID are the primary key together because the combination of these 2 columns can uniquely identify the row. Basically, a composite key is a combination of 2 or more columns in a table that can be used to uniquely identify each row in the table. Uniqueness is only guaranteed when the columns are combined. When taken individually, the columns do not guarantee uniqueness. The next term that we are going to talk about is functional dependency. Basically, functional dependency happens when there is a composite primary key in the table and some columns of the table are related only to a portion of the primary key, not the entire primary key. Let's take a look at an example here. So here you will see a sample record from invoice table. This table has 5 columns: client ID, product ID, date, quantity, and client name. This table has a composite primary key. Client ID and product ID together define the primary key of this table. So as you can see, date and quantity columns are different for every invoice. And again, as we have a composite primary key, each invoice is defined by client ID and product ID. So these 2 columns are okay. They are dependent on the full or entire primary key. How about client name? Basically, client name is related to client ID only. So client name is not changing based on the entire primary key. It only changes based on the client ID. So as you can see here, there is a functional dependency. as client name is related to a portion of the primary key only and not the entire primary key. In this case, we say that there is a functional dependency in the table. Next term that we are going to define here is transitive dependency. Basically, transitive dependency happens when there are some columns in the table that are related to a different column other than primary key. Let's look at an example here. So here is the invoice table again. It has invoice ID, date, quantity, client ID, and client name. So in this case, there is no composite primary key because invoice ID is unique per invoice. Let's look at the client name. Basically, client name is not related to the invoice ID. So client name is not changing based on the invoice ID. It's related to client ID, and client ID is not part of the primary key. So in this case, we say that there is a transitive dependency in the table. Next thing that we are going to look at here is the relationship between entities or tables. There are different types of relationships between two entities or two tables. The first type that we are going to look at is a one-to-one relationship. As an example, let's look at employee table and a resume table. So in general, one-to-one relationship is a relationship between two tables where a single row in one table is linked to a single row in another table. In this example, an employee has a resume, and a resume is owned by an employee. What it means is, for every employee in the employee table, you have one record in the resume table. And for every resume in the resume table, you have one record in the employee table. This type of relationship is not technically used in normalized database design. The reason is, for a one-to-one relationship, two tables can be combined together and form a single table. In this example, resume can be a column in the employee table. However, for some scenarios, you have to break the table or split the table into two different tables and have a one-to-one relationship between them. For example, one scenario that you might want to use a one-to-one relationship, or you might have to use a one-to-one relationship, is when you're working with Access database. So when you're working with Access, the number of columns that you can have in the table is limited. So sometimes, if the number of columns in the table are exceeding the limit, then you have to split the table into two different tables and have a one-to-one relationship between them. Next type of relationship that we are going to talk about here is one-to-many relationship. I would say this type of relationship is the most important relationship that you will use in your design. As an example, let's look at employee and department table here. In general, one-to-many relationship happens when for each record in one table, you have multiple records in the other table. In this example, each employee works for one and only one department, but each department can have multiple employees. So there is a one-to-many relationship between employee and department tables. Next type of relationship is a many-to-many relationship. For example, the relationship between employee and project table is a many-to-many relationship. Many to many relationship happens when for every record in one table, you have multiple records in the other table, and other way around. For every record in the other table, you have multiple values in the first table. So in this example, multiple employees can work on every project, and every project are worked on by multiple employees. So the relationship here is many to many.